Welcome to another day on the Journey Chez Chem. Please do the 2 warm-up questions to the best of your ability. And these 2 are, first you must find the empirical formula. So we change our percents to grams and then grams to moles and then divide by the smallest to get the ratio of the atoms. So do the best you can. And in number 2, you need to make sure that you read the question so that you know which one is the hydrated compound and which one is the anhydrous compound. And change those to moles and get your water to moles and divide by the smallest. And do the best you can, and we'll go over it in a moment. In number 1, we are assuming that we have 100%, and therefore 100% would be 100 grams. 59.0 grams is carbon in adrenaline, and I thought it was interesting that adrenaline, that we can figure out its empirical formula. And 1 mole of carbon has a mass of 12.0 grams, and therefore I get 4.9166 moles of carbon. I'm also given 7.1 grams of hydrogen. And 1 mole of hydrogen has a mass of 1.0. And therefore I get 7.1. And I am going to add these zeros so that I am consistent with my calculations. I have 26.2 grams of oxygen. And 1 mole of oxygen has a mass of 16.0 grams of oxygen. And therefore, I have 1.6375 moles of oxygen. Now, in order to get the amount of nitrogen, I must add up these numbers. 59, 7.1, 26.2, and when I add them up, I get 92.3 grams that are taken care of. I have 100 grams, and therefore I have a remaining of 7.7 grams of nitrogen. 7.7 grams of nitrogen, and I change that to moles. 1 mole of nitrogen has a mass of 14.0, and I get 5.5. Once I transfer them all into moles, now I can make a comparison. And then I divide by the smallest. Well, my nitrogen is the smallest. Therefore, I have 1 nitrogen. And my oxygen, I have 2.9. And my hydrogen, I have 12.9. And my carbon, I have 8.9. Now we are within a tenth, and so we can round. And I have 9, 13, 3, and 1. Therefore, my empirical formula is C9, H13, O3, N. That is my empirical formula. Now, in the problem, I was asked for the molecular formula, and I was given the molecular mass. Therefore, I add up my empirical mass. I have 9 carbons, and I have 13 hydrogens, and I have 3 oxygens, which is 16, and I have 1 nitrogen. Again, I multiply these numbers out, and I get 108, and I get 13. That was simple, wasn't it? And 3 times 16 is 48, and 14. And when I add those numbers up, I actually get 180. My molecular mass that's given in the problem is 180, and I'm dividing by my empirical mass. So the molecular mass is divided by the empirical mass. And you can see that it's 0.9, and that's close enough to 1. Therefore, the empirical formula is the same as the molecular formula. It can be just 1. Now, we know that it should be a whole number, and it is close enough to 1, and that's our whole number. If I had a number like 3, then I would multiply these subscripts through by 3, and that would give me my molecular formula. And that's how we do number 1. In number 2, it's very important to read and understand what information the question is giving you. And you are given the mass of the hydrated crystal, just like we did in the lab, and the mass of the anhydrous compound. The anhydrous compound is the one that we're interested in because that's the one that we can change to grams per mole, because we don't know how much water is in that compound. Therefore, I take the 1.03 grams of lead-2 acetate and change it to moles. And 1 mole of lead-2 acetate has a mass of 325.2 grams. Now, it's at that point, this formula mass, that many students make an error. And I would suggest that you write them out. Lead is 207.2 AMU. And you have 4 carbons, and 4 times 12. And you have 6 hydrogens, and 6 times 1.0. And you have 4 oxygens, which would be 4 times 16.0. I write them again after I multiply. And I have 48.0 for my carbons, and 6.0 for my hydrogens, and 64.0 for my oxygens. And when I add them all up, I get 325.2 AMU. Now, in this case, we need to use the AMU as grams per mole. And the mole is where I'm going, that's what I'm looking for, and grams is what I need to cancel. And therefore, I get 0.003167 moles of the lead-2 acetate. Now, at this point, I need to figure out how much water I have. Well, it told me in the problem that I had a sample that was 1.21 grams. And also that I had 1.03 grams of the anhydrous compound. Therefore, that is remaining 18.18 grams of water. And then I take that grams of water and change them to moles. 0.18 grams of water, and 1 mole of water is 18.0 grams. And therefore, I have 0.01 moles of water. And then, very much like empirical formulas, I divide by the smallest. And when I divide this number by itself, I get 1. And when I divide this number by the smallest, I get 3.1, and that's close enough for us, as long as it's within a tenth. And therefore, the ratio is 1 lead-2 acetate to 3 waters. And the way I write the formula is I write the compound with a multiplication and 3 waters. And that would be my final answer. That is the formula for the hydrate. But the ratio is 1 to 3. So it's very important to understand the terminology. And that's number 2. Now, your facilitator has the worksheet answers for you to go through and make sure that you understand how to do those problems, because we're getting very close to that assessment. And we have talked about how to go from grams to formula units or molecules, how to go from molecules back to grams, how to do an empirical formula, a molecular formula, percent composition, and hydrate formulas. So we've learned a lot of various different types of compound formulations and mathematics, and I know that you're getting better at these types of problems. We'll keep practicing for a few more days, but the assessment is just right around the corner. Well, that was some fun, and I hope you're getting better at this and feeling more comfortable, and I can't wait to see you tomorrow. Bye!